Okay, this video here is long overdue. This is Sohcahtoa trigonometry of right angle triangles or 90-degree triangles. Consider this triangle here. Where that's 90 degrees, this is an unknown side, we'll call it H. That's 38 degrees, and this is a length of 15. And we're trying to figure out this side length here. Sohcahtoa is an abbreviation for three different equations. The sine of the angle is opposite over hypotenuse. Sine is opposite over hypotenuse. Cosine of the angle is adjacent over the hypotenuse. And the tan of the angle is opposite over adjacent. So the sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. Now what those words mean, if this is the angle in question, the side length across from it we call opposite. The shorter of the two side lengths beside it we call adjacent. Adjacent literally means beside. And the long side, the one that's across from the right angle, we call the hypotenuse. So to solve this one, looking at that angle, I have the hypotenuse and I'm looking for the opposite. Hypotenuse and opposite are in the first one right here. So I'm going to use the sine. That means that the sine of the angle in question is the opposite length over the hypotenuse. In this case, the sine of 38 is equal to opposite, which is labeled H, over hypotenuse, and the hypotenuse value is 15. Again, how do I know that I'm using sine? In this particular question, I'm given the hypotenuse and I'm given the opposite side length as the thing I'm looking for, whereas the adjacent side length is not of interest. So I look at this list and the only thing that involves opposite and hypotenuse is sine. Now I just need to find H. How do I find the sine of 38 degrees? Now you're probably going to use your calculator, but I recommend as you get started you use a trig table. You'll understand it better. The sine of 38 degrees. So I'm looking at my list of angles and I find 38 degrees. And at 38 degrees the sine is 0.61566. So that is 0.61566. And that's equal to my unknown side H over 15. Now I want to get H all by itself. I'm going to multiply both sides by 15. So H is equal to 15 times 0.61566. Which is 9.23. So this height is 9.23. I'm going to show you another example now. In the next example, we're looking for an angle. So consider this one here where we have a side length of 5, a side length of 7, and we're looking for this angle x. Now, looking at Sohcahtoa, considering this is the angle, the side length across from it we will call opposite. So this is opposite. And number 7, this could be tricky for you, is this adjacent or hypotenuse? Remember, hypotenuse is the long side. The short side beside the angle is adjacent. So I know the opposite, I know the adjacent, and I'm looking for the angle. So I need to find the formula that involves opposite and adjacent. That's this one here, TOA. That is the tan of the angle is opposite over adjacent. So I'm going to go ahead and write that down. The tan of my angle is opposite over adjacent. And in this particular case, the tan of angle X is opposite, which is 5, divided by adjacent, which is 7. I'll go ahead and use my calculator here. 5 divided by 7 is 0.7143. Now teachers, this is why I recommend you teach trig with a table at first, because that way there's no confusion as to whether you're using sine or inverse sine, tan or inverse tan. It's just clear as day on the table, whether you're looking for the angle when you have a ratio or when you're looking for a ratio when you have an angle. So the tan of X is 0.7143. So I'm going to look in the tan column for 0.7143, or as close as I can find. And the closest I can find is 0.7002. That's closer than 0.7265. So somewhere in between is going to be my answer. And 0.7 is the tan of 35. And 0.726 is the tan of 36. So the angle I'm looking for is between 35 and 36. I'm going to call it 35.5. So X is equal to 35.5 degrees. Now if you use your calculator and find the inverse tan, you'll get more accuracy in the decimal place. But when you're getting started, believe me, you're going to understand this a whole lot better if you just get yourself a trig table that goes up to 90 degrees and learn to work successfully with that. Got a couple minutes left, so I'm just going to do one more example real quick. I'll do an example where I'm looking for the hypotenuse, because most people find that the most difficult. So let's say I've got an unknown hypotenuse, and that's 30 degrees, and let's make this 17. So I've got my angle in question is 30, 17 is the adjacent side, and A is the hypotenuse. Adjacent and hypotenuse go together with cosine. Cosine of the angle is adjacent over hypotenuse. So I'll go ahead and write down that the cosine of 30 degrees is adjacent, which is 17, over the hypotenuse, which I've labeled A. The reason why people often get these wrong when they start is the variable you're looking for is on the bottom. You got to do an extra step here. Multiply both sides by that variable. So I'll end up with A times the cosine of 30 is equal to 17, and then divide both sides by the cosine of 30. So A is 17 divided by the cosine of 30. Now what's the cosine of 30? I'll go to my trig table, and for 30 degrees the cosine is 0.866. So that's 17 divided by 0.866. Now remember, in the last one we were multiplying, in this one we're dividing, because what we're looking for is on the bottom. So we do a couple of algebra steps to get it on top before we isolate it. I'll go ahead and do that division now. 17 divided by 0.866 is 19.63. So this side length here is 19.63. And a good quick check, the hypotenuse must be longer than each of the other two sides.